What I would like to do now is move on to introduce Dr. David Soldani, Adjunct Professor of the University of New South Wales. David, welcome. Thanks for joining us.
Hello, thank you so much for having me today.
Our absolute pleasure, David. David is, I would almost say, a master in wireless networks and communications. David has had, more than 20 years split between the giants of Nokia and Huawei, as well as being an adjunct or visiting professor to a number of universities around the world. So welcome, David, and take us away for a bit of a introduction into 5G and the cloud opportunity.
So thank you so much. And what I have prepared today is to illustrate to you what Patrick and Robert presented earlier could be applied or accessible through a 5G connectivity. And the focus of my talk is on the 5G Cloud X. Specifically, I'd like to illustrate you X being augmented and a virtual reality offering. So first, I'd like to present my vision of 2025-2030. So my vision is that all intelligence will be connected with the zero trust model Robert presented through digital twinning. And that will be done using 5G and later 6G. And the machine reasoning will meet the machine learning at the edge. So intelligence, I define intelligence are basically functions with the ability of representing knowledge, processing knowledge, and make a decision. So here you have an example of an intelligent platform that is a ICAB. ICAB is from the Italian Institute of Technology in Italy. And I'm using now a couple of slides taken from Roberto Cingolani and Giorgio Metta to prove that artificial intelligence today is really costly and inefficient. Let's have a look at the numbers. So here you have the son of Roberto Cingolani and the humanoid, the son of Giorgio Metta in comparison. So we have humans that are basically grown on around 6 elements, and we are about 40 watts. So that's the power our brain dissipate to perform tasks I think will never ever be performed by machines. And an evidence of that is that this humanoid here, which is one of the most advanced platforms, robotic platform in the world, would require, say here on this slide, 200 watts to perform a part of the task that this boy would basically do without thinking, without, say, any kind of policy behind, because our brain works differently. Now look at the numbers. What we have is that with a chocolate, this boy would work, perform, do anything for about a week, and an equivalent of energy, say, provided to ICAB would allow him only to work for about 2 hours. So the first, basically, conclusions is that the power cost per operations is from 1,000 to 5,000 higher in machines. So what are the consequences of this? Apart from the costs of this element, what we need to do is to reuse this intelligence, reuse this capability. So what we want to do is to move all the intelligence residing in the robotic platform to the edge of the network. So we need to have the edge and work at the edge of the infrastructure, edge meaning close to the end user, practically close to the radiating antennas in the downlinks of the base stations. And that is necessary because we also want to reduce latency. So moving out capabilities from the platform to the cloud means that if I make a decision here, an end-to-end from a decision in action has to be less than, say, 5 milliseconds. Otherwise, basically, I have a discontinuity between a decision made centrally to what the task is performed locally. So the second trend I see extremely important is, as I mentioned, in my vision, that the machine learning requires to work with the reasoning, because the machine learning as such has many limitations. So the pattern recognition fails many times. And one of the problems, for example, biases. Then what I think is that we need to play with digital twins. So we need to prepare for an infrastructure service and platform to deal with the cyber world. So we need to really copy the physical world and reproduce that in the cyber. And that this is necessary because we can no longer wait for reducing the impact on, for example, climate change. So we need to improve our efficiency, productivity, and definitely reduce our CO2 emissions, namely greenhouse gases emissions. And finally, looking at the shift from the 5G to 6G, it's now we are having a fundamental shift in paradigm is to move from the Internet of Things to the Internet of Intelligence, supporting the zero trust model that was presented earlier, and I couldn't agree more. So where are we with the 5G? Just a couple of slides to be on the same page that what we speak is through and real. So 5G is on, and just a couple of slides to give you a view on the global landscape taken from a GSMA report. And last year, we have that as of today, we have assigned spectrum for 5G globally over around 40 markets, and more than 128 operators already today have received the spectrum, and the radiations is within the 3 bands. Relevant is the mid band, that is between 1 to 6 gigahertz. I'm thinking of the C band, where we will anchor all our radiations using the new radio. The new radio is the wireless interface of the 5G, complementing the access using the LTE or the 4G services. So live networks all over the places. Australia already, you may benefit. I was downtown, I saw on the mobile phone up to 350 megabit per second. And as of today, we have more than 110 operators that have planned or already launched this service. Looking at the terms of the connections or connectivity and the global reach and economy of scale, we see on this slide that today we are having in place already more than 234 million connections. Majority of those are in China. China will remain definitely the largest market for reaching out about 20% of the global penetration, namely 1.8 billion connections, with again China reaching out in proportion the 40% of the connectivity globally. It's of course intended that it's not just about China. Actually, if you look at the relative numbers, the major penetration by 2025 is expected in North America, followed by Europe, Asia Pacific. And all these 3 regions will basically account for 90% of the 5G mobile connection forecast globally by 2025. The devices are there, and if we take a look at the recent document published by the GSI, we have that we have more than 700 announced devices, 431 commercially available today. And here you see on the pie chart the proportion of available devices. Yeah, we have plenty of smartphones, about 50%, half of the cake, but we also have a variety of fixed wireless access custom processor equipment, which is nothing else than a modem as we are using today for accessing the NBN, for example, here in Australia, using cables or fiber. We do also have plenty of other form factors. I'm thinking of models installed in on a variety of robotic platform, including drones, so unmanned area vehicles. So the frequency I've already explained. So massive communications in the C-bands. In Australia was already assigned a band back in 2018. That's where we are receiving services. But along with that, we are now aggregating the transmission using the LTE dual connectivity or carrier aggregation to lower bands, and Australia will be soon make available also spectrum in the millimeter wave and at in the sub 1 gigahertz, namely the 800 and 900 megahertz for massive large coverage, including coverage, say, in rural areas and countryside. A quick view on the roadmap. This is the 5G standard roadmap. So 5G, but also 6G. So today, as we speak, we have already completed the specification of two 5G releases. So release 15 that you are currently enjoying in the field, massively deployed in both in its non-standalone configurations, which is just about putting a base station next to your 4G system, and in its standalone configurations or architecture, which is an end-to-end fresh new system, not only therefore using the new radio as a data stream, but also through all the signaling and with the introduction of the 5G core network. So both releases, the support an enhanced mobile broadband experience, but also ultra reliable connection, ultra reliable low latency communications. And when we combine the two features, we already today fully meet the ITU requirements. That is the vision we depicted back in 2015. Now we have further announcements, so we will integrate massive machine type of communications, that is release 17, for then start thinking of a new set of use case category and start integrating the research already massively ongoing, especially in terms of enabling technologies architecture, on study items, so technical reports, for then specifying the 6G and enjoying those services by 2030. So where are we today in terms of use cases? So we also understand how we may position the platform presented in services by the earlier speakers on our 5G communications system. So 5G, the one you're having in place, deployed today, supports three main use cases already mentioned: EMBB, MMTC, URLs. Okay, now by 2025, with the release 16 and 17, and beyond that, we will be able to exploit all spectrum and radiating across the whole frequency range up to 1 gigahertz, and the system will be complemented by artificial intelligence with the introduction of a parallel plane or machine learning pipeline. So what kind of new user scenarios we are having in front of us? So first of all, we will be able to integrate services in terms of uplink-centric broadband communications. And that is about smart factoring, smart mining campus, and so forth. We will also support real-time broadband communications in terms of virtual augmented reality, mixed reality, and so forth. And that is what I am currently especially focusing on during this presentation. And beyond that, equally important, it is the support of integrated communication and sensing, which will be the most important use cases, also supported by 6G. Now, let's take a look at what I mean by RTBC. And I'd like to start for illustrating how explosive is the growth of VR AR in the next 2 to 3 years. It's taken for granted, but we can get from this picture that, yeah, we are already enjoying those services. So if you happen to be in South Korea, 5G monetizes, especially through an offering of VR at 4K, and those are basically the bands and the latency supported by the current 5G deployed system in especially non-standalone configurations. So from this here onwards, we will have capability in the field of supporting 300 megabits per second, reduce latency down to 15 milliseconds, which means we will be also capable of carrying along a resolution of 8K. For then by 2023, maybe 25, we will reach out truly an ideal full immersive experience in terms of augmented and virtual reality or mixed reality. So today we are pretty much still here where we are after our handheld devices, 2, 3, 4 smartphones, each of us, and what we are expecting now to move towards the concept of the digital twin. I no longer want to wear any kind of device, and possibly what I wear has to be extremely cheap, and I will show you how we intend to achieve that. But in particular, I want to have an experience and make use of the digital twin, an experience that practically I've just consolidated some of the recent white papers coming out from Microsoft. This is an example of HoloLens 2. We are now thinking of going beyond to integrate directly a 5G connectivity into the goggles. So here already we are assisting over plenty of possibility and use cases. So we are having mixed reality for manufacturing. We also have mixed reality for healthcare and also for retailers thinking of a digital marketing type of offering. So today we have already plenty of applications, and looking at the capability of the 5G, 5.5G, and later with introduction of 6G, we could also shift and enjoy much more complex and immersive services such as virtual reality for socializing, and also virtual reality applicable to any kind of possible industry. And above here, just have some examples. Integrated communication and sensing comes along with that. So it's not just about integrating now what you can capture with your glasses. I'm thinking of now that the next step is really to integrate and augment what you see, what you enjoy, but also what you make use of from other sources of data, sensing type of information. And here you may see how we can integrate the uplink stream received from drones. That requires to provide a sky coverage of around 300 meters. It's a requirement from the standards. In order to have those services, you need to have an uplink speed, which is quite challenging and unachievable with 4G, by the way, of more than 50 megabits per second, and the latency due to the controlling options, uplink, downlink, has to stay below 50 milliseconds. So we have a number of new use cases, and fundamental enabler is definitely to have the regulatory, so the right regulatory in standardization in framework, so that we can go through all the current barriers and come along with an ecosystem and platform that support plenty of use cases and applications. So our predictions below are in terms of the connected objects, UAV, and it's a UAV in this particular case, and the market size. We are estimating by 2025 to reach and connect more than 50 million type of devices, attempting tapping on a market of more than 80 billions, which, by the way, is smaller than the yeah, that what we are expecting by bringing gamings on a cloud age platform. Yeah, the other user scenario is about uplink-centric broadband communications. And a characteristic of the new radio is to dramatically increase the speed from the devices to the network. That allows us to do many things and play with many categories of IoT connections. Here you have example of different IoT scenarios in terms of deployment requirements and the coverage requirements. So for the industrial IoT, we usually tend and we need practically to deploy a private network. It has to be really trustworthy and reliable, 5 nines and more. And typically we have a private system, or it is an offering that we achieve through network slicing end-to-end, and at the age where we could really meet the performance in terms of latency. Massive IoT requires large coverage areas, and here I think it will really fly when we will integrate our access network, currently cellular, with the satellites. Satellites coming now in release 17, looking back at my roadmap, and that will be also an access system, not as a backhauling, but access. So my device at 2 gigahertz will be capable to communicate via satellite, and also I could increase the bandwidth by using other type of devices, specifically targeting a satellite type of communication that could be installed on larger platform. But with the satellite, definitely we will achieve a complete coverage of the Australia and the global. And then we have other type of IoT and applications. And on the right here, you may see what kind of system capability you need to have in place to meet those the requirements of the particular users scenario. Today we are here, no problems for broadband IoT offering. We support nice 100 to 1 gigabit per second. And then later with the announcement of 5G, we also think of integrating other type of application and industrial IoT, but also for critical IoT. So bringing the IoT to the critical infrastructures. Requirements of the service application in order to enable business to consumer, business to the home, households, and business to business in terms of a wholesale offering are represented on this slide. So today we are pretty much here. I mean, we do have an excellent capability in place. We can't complain about that. But if you would like to achieve more and really have an ideal type of experience and many more service applications on top, we need to further enhance the system, because as you see here, the characteristic of those service applications demand for a much higher bitrate reductions of latency. And in particular, when you want to deal with the vertical sector, you need to be 100% about 5 to 6 9 reliable. So you cannot miss out a connection or have a problem in the service if a robotic platform is connected. Now, I would like to show you the concept quickly on the Cloud X, Cloud XR, because I think this is definitely the killer application. And in particular, it is what Australia should have in place to create many jobs and say allow plenty of new opportunity among a number of sectors. The Cloud X, what is it? What am I talking about here? So let's try to understand. There's also a position what the earlier speaker discussed earlier on a 5G infrastructure. So 5G here, I have reduced to 3 main blocks. You do have a base stations where you access the services through wireless, and it has to be wireless, the connectivity in the future, because we need to have an element of mobility. Even the robots are moving within a factory. So it has to be wireless. And the wireline has to be only for backhauling. So the access, I repeat, has to be wireless. We may discuss whether it is wireless cellular, wireless satellites. My answer is both of them. Said this, then we have the core network that basically takes care of the establishment, the communication, mobility, security, anything and everything, so that the system, the communication is maintained end-to-end. And then you have the devices. The devices currently we are talking about the CPUs, which has the element that you put at a home and allows you to connect the 5G services. And then you have your devices that communicate through this new box or new modem using the Wi-Fi, example Wi-Fi versus 6, otherwise you deteriorate the services the 5G may support. What we are targeting now with the organization listed on this slide is to integrate the two things. So we have a possibility of further enhancing the HoloLens with a direct support to the 5G services, hence allowing us to move beyond a simple Wi-Fi coverage. Okay, now, what can we do here? So why do we need a 5G? So I've already explained, 5G brings us speed, latency, reliability, security, and privacy at the very service level. And that is fundamentally important because the pipe connecting these two endpoints will be simply invulnerable. Now, what is key here? It is that why the 5G and not 4G? Because the latency reduced and reliability and especially the speed will allow us to move all those key functionalities currently implemented at the edge. You may think of the rendering capability, you may think of a tracking, recognize objects capability, and so forth, to shift them from here to the edge. So we want to bring them all here using the multi-axis computing platform, which is currently meant to be integrated with the 5G communication system starting from release 17. Fantastic. You may think of a 5G now that the 5G core network will be enhanced to support the interfaces between the multi-axis edge computing platform and the end user device within the stack of the 5G protocol, therefore making this system extremely reliable, robust, because you see here, if you think of introducing a platform close to the edge of the network, you may have plenty of vulnerability and evasion from both sides. We don't want to see this. Therefore, we will enhance the 5G system to support the multi-axis edge computing. And on top of this, we will bring all the service applications. And in this particular scenario, I'm presenting what will be about the cloud XR, cloud edge. That's the platform we will have at the edge in communication with the user plane function that has to be modified, the 5G system. And above that, we will have plenty of applications. This is just an example of virtual reality and augmented reality where the capability of rendering are currently extracted for the devices, make them extremely cheap, extremely performing, light, perform at the edge, integrate together with interaction servers, and then we may complement them with many other applications, AI, analytics, and in particular, what we think here is to introduce the secondary security dimension, which ranges from authentication, encryption, integrity, and authorization that could be done simply on top, in addition to supporting the AKMA functionality, which is a way that the 5G authenticate the applications running on the multi-axis edge platform. The offering will become scalable, will meet all the requirements you may find within the government initiative in Australia. You may think of the 5G innovation initiative, the modern manufacturing initiative, and is of 10 days back or a week or so back. the requirements coming within the digital economy strategy Australia. So that's definitely the platform we need to have in place in this country, so that we can enable plenty of jobs and really transform the way we live, the way we work, the way we have fun, and the way we are really learning. So we need to start from smart education and training with a fully immersive experience, because what we remember mostly are through images, interactions, not much reading, books. This is just, you can't remember that. Today you will remember me that I'm moving my hands, so that I have my hologram. You won't remember this, it is written on the slide. That's why the first application will be definitely on smart educations and training, so that we can represent things like electromagnetic fields or explore things we cannot touch, but we could play with the hologram type holographic rendering. And then beyond that, I think we need to bring those applications to smart manufacturing, tapping on the modern manufacturing initiative. Healthcare, you see also the massive investments the government is placing on aged care. And then I'm thinking of digital marketing. Here you have an example of how we would like to achieve the marketplace. Marketplace means an ecosystem digitalized where the customer or the end user, being the customer, consumer, or tenant coming from the vertical sector, we simply access those services through subscription. That's why we want to achieve a marketplace. Practically, ultimately, I think a ultimate goal here is to achieve the vision, which I already published back in 2015, because our ultimate goal, it is about shifting from the current Internet of Things to the Internet of Intelligence. So just to conclude, I think that the capability or possibility and ability we are having now of bringing together the devices that, as I said, will become cheaper, will become simpler, will become capable of receiving video streaming, but also capable of performing the same tasks using much less energy, as all this intelligence will go to the edge cloud. The second element, we need to have a 5G wireless. So we need to have a wireless absolute infrastructure that meets those technical performance requirements, especially in terms of speed. So as I said, we need more than 100 to up to 20 gigabit speeds, and then latency, we need to go down below 10 milliseconds, reliability 5.9, and so forth. And then beyond that, we need to come along with a multi-access edge computing platform on which we will install, run plenty of service application that we will target to offer as a scalable marketplace, where you may find many benefits. Some of those are illustrated on this slide. Benefit to the end user, because I will really, truly have time to consume services, and not like today, like my son last night spent 4 hours to install on his desktop a game. I don't want to do this. I don't want to do this anymore. I want to have everything running on my edge platform, and just access that as a video streaming, uplink signal, just simple commands. Benefit to the device suppliers, we target to have an ecosystem, price will go down, and we will have the possibility of a large adoptions of each elements. And benefit to the application service provider, as there will be plenty of applications accessible through a single marketplace. The benefit, of course, for the operators, they will finally have an argument to say, hey, I'm not only your bit pipe, I'm not only bringing you connectivity, but I finally have my capability in place to play the role of an aggregator, or even think of offering specific services. So thank you so much. That's pretty much what I wanted to share with you. And on the slide set, I have integrated with a few of my recent public talk and presentations, where you may go deeper in any of the directions I attempted to mention today. Thank you so much for having me.
Thank you, David. I don't know that for many of us going deeper at this time would be the first words that would come out of our mouths, but an excellent session and highlighting, I guess, your absolute depth of knowledge in this topic, David. Thanks everyone for listening into that session. We are going to move on to some Q&A now.